So here's how the sequence reaction would work. You have the strand you're trying to sequence. You have the primer that is complementary to some part of the strand you already know the sequence of. So the primer would line up here and then go like, okay, these are not complementary to each other. And then in our case, we just slide down and you'll go like, okay, two colors lined up. With these two colors lined up, are they complementary? Yes. G is complementary to C, looking good. That to that. T to A, looking good. And then here again, green and blue. Okay, good. This is where my primer is going to hybridize, so line up with the DNA sequence I'm trying to obtain. This is the part I don't know that I'm going to learn, right? This sequence I had, and I'm trying to learn what's over here. So then what happens is the primer lines up with the DNA sequence you're trying to read. And then the enzyme called the DNA polymerase is going to read what is this next letter. So the yellow one is a T, so it will put an A. And which A it puts, if it is a deoxy or dideoxy, is at random. All we know is that it puts an A. It doesn't see a difference between a dideoxy and deoxy. So, okay, here's all of them. So I line them up here from shorter to longer because after all these different new strands of DNA get made, then you run a gel. So you put all the DNA fragments on the top of a gel. And this doesn't really mean anything with gravity because the way they migrate down is mostly because of an electric field that you apply to this. So what happens is the less bulky molecules, they will travel faster. So this would be as the smaller molecule because it's only the primer plus one nucleotide. This would be the second smallest. So they would be stacked up from longest to shortest. Okay, but that's the running gel is the second part of the sequencing. The first step is to make the new strands, right? So the primer lines up with DNA. The enzyme reads what's the next letter here, therefore, which is the next nucleotide I should add. If your sequencing reaction only had dideoxynucleotides, so do only have these ones that I wrote in darker color, then every strand you make is basically this long because it adds this dideoxy here, and it cannot add anything next. No, there's no incoming here because of this hydrogen here. It needs to be an OH to react with the new nucleotide. So if it's just an H, it stops here. So that's why when you do a sequencing reaction, we do a mixture of, these are deoxy, so if these were beads, a bead is a little stub that you can like plug the next bead in. And it's a mixture of those and the dideoxy, which are marked with some fluorescence. So, all right, so first step, you make all of these strands. They're not organized like this. But at random, the polymerase is going to add either a deoxynucleotide or a dideoxy. In this game, I cooked it so that I had exactly the number you need to get this. But in the reaction, you add actually, I don't know, tera numbers of these guys because you add 1 to 2 tera number of molecules of these guys. So in theory, that's how many molecules you're making. All right, so okay, the new ones get added, and then we run this on a gel. The shorter ones run faster. So, and these guys are marked with a dye, and there's a laser at the end of the gel. So like a laser over here, which I told you if this is a race, so they all start up here. The smallest one would be fastest, at least in terms of nucleotides, because there is a whole matrix they have to run through. So the smallest one is fastest and crosses the finish line here first. And that laser, which is the finish line, reads what color is this guy that just arrived. So it's like B. No, this guy crossed the finish line and he reads, oh, it was an A and it was a red. And then people know that they labeled the A in red. The next one runs down here. I'm gonna move the finish line over here, but then he reads that one. Then he reads that one because only these are the ones that are marked. We need these other guys so that we can get to that. Yeah. So your new sequence, when you receive DNA sequence from the sequencing company, it will have your primer sequence, which you already like, oh well, whatever, I already knew that. But it's kind of reassuring that they sent you your sequence. So they send you your primer sequence plus these guys here. Yeah, got it? Wait, I want to change the video.